Okay, so 2.2, proving lines are parallel. That's what we're going to be doing. That's essence everything we're going to be doing. Converse. Okay, everything last week was a theorem, right? Converse means backwards. Okay. So I said if two lines were parallel, the corresponding angles were congruent. Now we're going to say if two lines and a transversal, so transversal is a line that hits both those lines, right? Form corresponding angles that are congruent. Then the two lines are parallel. So just backwards of last week. The corresponding angle theorem said if two parallel lines are intersected by a transversal, then corresponding angles are congruent. This one says if two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. Okay, so what could we now add to our two lines? The arrows. So the converse of the alternate interior angle. So the alternate interior angle said if two parallel lines cross by a transversal, then the alternate interior angles are, what were they? Alternate interior angles are what? Congruent. So now it's going to say if two lines in a transversal form alternate interior angles that are congruent, then the two lines are parallel. How do I know that angle 1 and angle 2 are congruent? What do they have? They have one little arc, right? Could I put two little arcs on both? Yes. So we now can add our parallel lines. Okay, so the converse of the same side interior angles. So what do we know about same side interior angles when the two lines are parallel? They are what to each other? No one knows. After all last week, no one. They're supplementary, meaning they're what? They equal 180. So the converse of the the converse of the same side interior angle theorem says if two lines in a transversal form same side interior angles that are supplementary, then the two lines are parallel. So 1 and 2 have to equal what? 180. Put that on there. Actually, I don't like how I wrote that. I must say plus equals 180. How about that? Okay, the converse of the alternate exterior angles. We know that alternate exterior angles are congruent if the two lines are parallel, right? So the converse says if two lines and a transversal form alternate exterior angles that are congruent, nope, I spelled that wrong. I forgot my U. Then the lines are parallel. No, last week we had vertical angles and we used that a lot, but vertical angles had nothing to do with being parallel, did they? No. So none of that vertical angles will not prove it. And they show these are congruent by the one line. I wish the pictures had like 2 lines or 3 to show you some different there. So those are the 4 that you are going to use to prove that 2 lines are parallel. If 2 lines are parallel to the same line, then they are parallel to each other. That is the transitive property. Underneath that, I would basically just write A is parallel to C. Yes, that's what it shows. Does it show A and C? Okay. And C is parallel to B. So therefore, A is parallel to B. Okay, so that's that transitive property, but with parallel lines. Okay, if two lines in the same plane are perpendicular to the same line, then they are parallel to each other. So what that says, there's not much to do. Perpendicular means they form a what? What kind of an angle? Right angle, a 90-degree angle. So this says that A, and the sign for perpendicular is like an upside down T, is perpendicular to C. And B is perpendicular to C also, correct? So that means that A is parallel to B. So we can use these also as definitions to prove lines are parallel. The transitive property, we have to know that they're parallel already, right? But this one, as long as they're perpendicular to the same line, they have to be parallel to each other, don't they? And remember, parallel means they never what? Touch. They never cross, they never touch. So there's our definition, so let's use it. You better draw a picture because you don't have a picture on yours, do you? And under the fourth one, like you will totally have a place, like draw it kind of where it is. Or down in here or something. I'll give you time. Very basic drawing. Don't get all creative. I don't need to know it's a gate, do I? I have a big rectangle, don't I? And I have something in the middle. And then I have a line that goes like this. I know this is a right angle. I know this is a right angle. We're not in art class. You see the perpendiculars down here? Well, not perpendicular. Right, right angles. Everyone got their picture drawn? We good? Okay. When building a grate, how does Bailey know that the vertical boards V and W, vertical means which direction? Up and down, yes? Straight up and down. V and W are parallel. So how does she know that this board, see it back here, is parallel to this board? I need to use another color besides red. Does that help to see it all? Can everybody see their paper good? They intersect the bottom board at what? 90 degrees. Didn't we just have that on the other side? It says if two lines in the same plane are perpendicular to the same line, then they are parallel to each other. Correct? So, I know, because, let's see, it also could be by the converse of the same side interior, couldn't it? Are these angles same side interior? Yeah. So, by the converse of the same side interior angle theorem. Or you could write, if two lines are perpendicular, I like this, it'd be easier to write, wouldn't it? So that's basically what your homework is going to be. It's like, how do you know they're parallel? By the converse of same side interior angle, by the converse of alternate interior, by the converse of alternate exterior, the converse of corresponding. Right? Okay, so next one across, we'll just go across. Bailey also needs board C to be parallel to board A. So board C to be parallel to board A. So what should the measure of angle 2 be? And why? Say it again. It should be 90. So angle 2 should be 90 degrees. Why? So what could you use? Because if it was 90 degrees, and you have 90 degrees right here, not alternate, it'd be same side. So you could use the same, the converse, right? The converse of the same side okay. Complete sentences. Oh my gosh. I'm going to learn how to use a semicolon. Y'all know a semicolon links to independent thoughts, right? Or an explanation. Okay, so what should angle 1 measure to ensure that the board is, ensure board B is parallel to board A? So we want board B to be parallel to board A.
Wouldn't that be alternate exterior?
Of what?
Never mind.
No. Well, B is here, yes. A is here. I need to know 1. Do I have other information?
Corresponding?
To what? Because corresponding would have to put, have to be, down here, right? And that,
Wouldn't it be 1 and angle 1 and 35 has to equal 180 because of the straight line?
yeah. Angle 1 and angle 35 have to be supplementary because of, again, the same side what? Interior angle theorem, right? So, angle 1 would need to be 180 minus 35. So I'm pretty sure that's 145. And again, so we could use converse of the same side. You guys gonna write a lot today? Yep. Interior angle theorem. Okay, so is line B parallel, or board B, excuse me, is board B parallel to board C?
Yes.
Why? Well, we proved that C was parallel to A, right?
Yeah, we,
And then
So C is parallel to A,
and
And-
B is parallel to A.
B is parallel to A, because we just did it over here. So,
and it's parallel to C.
B and C.
Oh yeah.
B is parallel to C. So are you going to be doing some explaining today?
Yeah.
Yes. Am I good? Okay, if angle 1 is congruent to angle 2. So I should put something on my picture. Right? So an arc at angle 1, an arc at angle 2. Okay, if that's true, which theorem proves that C is parallel to D? The converse, right?
Converse of the alternate interior angles theorem.
The converse of the alternate interior angles theorem. You guys gonna know the names by the time you're done with your homework today? Yeah, huh? Okay, so now it says if angle 2 is 4x minus 6, and angle 3 is 2x plus 18, what value of x makes, I think that should say makes, A parallel to B? Okay, so A to B. Yes? Well, if A is parallel to B, what would those two angles have to be to each other? They have to be congruent, don't they? Now, my problem being is 1 and 3 are not on the same transversal, are they? So I would have to get from here to here. And 1 and whatever angle this would be corresponding, correct? And then could I move from here to here?
Yeah.
And would they be corresponding then? So if 3 is corresponding to this angle, and 1 is corresponding to that angle, so they should be corresponding to each other. Again, is that the transitive property? Okay, so they should be congruent, so I need to set them equal to each other. So solve that. Did you get 12? Okay. Why? Well, you can finish.
No, it's not.
Just forget she said anything.
Okay. Questions on that before we go? If you're not quite done, finish it up. It's 12. Didn't mean to spoil this phrase.
I already got it because I got 24 and 2 because I already knew it.
Okay. Okay, so using the converse of the same side interior angle theorem. I think that angles, it should be a theorem. I'm pretty sure, not postulate. It should not be postulate. Okay. What equation shows G is parallel to H? So same side interior angle. What does that mean? What are they? What's my magic number? What? Same side interior angles. What do those angles? What? Supplementary. So what is that number? 180. So if I do what? I add those two, they should equal what? 180. Okay, so we want G to be parallel. So G to be parallel to H. Yes? And so for that to happen, we need to use A transversal. Do you want 1 and 3 or 2 and 4?
2 and 4.
2 and 4? You guys okay with that? Okay. So what would 2 and 4 have to equal? 180. So the measure of angle 2 plus the measure of angle 4 would equal what? 180. Did I just write an equation? Could I have also said the measure of angle 1 plus the measure of angle 3 equals 180? Okay, so when your book says write an equation, you need to have unknowns. Do we have unknowns? We have angle 2 and angle 4 are unknown, but I do know they equal what?
180.
180. So when it asks you to write an equation to do something, they seriously want you to write an equation. It's going to have variables in it. Make sense? That's all I got today. So you guys can get started on your book assignment. Really quick though, your homework grades